Hi, ECS 36B students, and we're moving into another chapter. Now we're looking at the topic of operator overloading, which is in the chapter 12 of our textbook. So let's recap about what we have done so far. We started with a complex system that we like to either modeling or solve a real problem. So in this picture, you can see that we have lots of people and they have a different type of concern. And we have a different kind of object, and then we have a different kind of interaction that those systems they are interacting with. So typically, in solving a large scale software system, that this is a target we would like to address eventually. And how should we start it? And as I started to emphasize since our first lecture, object-oriented principle is a good way for us to modeling and representing such a large system. So we can start doing object modeling. For example, here we try to see that within this large complex system, we need to model a concept called box. Just like a chapter 11, we look at variety of boxes. And we also want to model another class called person. So in this slide, I show you we started with these two particular classes. And classes essentially is a way we abstract from the real system and use this as a basic building block for us to start to reaching out to capture the whole complexity of the targeted system we would like to build eventually. And for example, now we're looking at the class box. All right. So in the class box, you can see that I show you an example, just like I show you in the second lecture, is box.h from your chapter 11 example. You can see that within this class definition, you have a private section and you have a public section. And within the public section, you define, among other things, member function. And member function is purposely defined such that other elements in the complex system, they can interact with this class box. And now I'm actually separating two different words here. One is a class. Class is a plan. Class is a design about how all the object within the class should look like, should share certain property together, should share the member function, should share the private variable. Therefore, you can see that based on this design, class box, I actually can create an object called box. So that's why last time you saw a program segment saying class box, first box. And that first box is an object instantiate from the class definition of box.h. All right, so just look at this slide. I do want to emphasize a concept. At this point, you already define the class box, and then you actually create an instantiation, which is an object box. And that object box represent what we call a digital twin about a real object in the real system that we would like to model. And this concept is very powerful because essentially the way we address to solve the problem in a real complex system is that we try to do a very good effort in providing a digital twin of every single object in that real system in the cyber world. And from now on, we are going to operate in the cyber world. In some sense, we're actually solving the real problem in the real world. So this, you have two things. One is the digital twin, one is the real complex system. All right. So, of course, having that box.h, which provide the interface or member function or public area for that class box is not enough. We have to implement that concept box.h as well. For example, that member function, we have to define in a separate file. Usually we call it box.cpp. And you can see that box.cpp, the first line must include that box.h, saying that it's include that interface definition class box. And then based on that, here we provide the source code for every single member function that's supporting the implementation of the box.h, including constructor, including later I will tell you destructor, as well as all the member function, such as last time we talked about volen. Volen is a member function that's very critical to support the operation of box. So that's box.cpp. It has the include, and it basically just provides the implementation. And also we have down here, this is main.cpp. I use the word driver or use the word test function. Means that this is a separate function or separate program from the object-oriented concept about box. But this program will leverage the definition about box and doing something. I mean, for example, this is the main function. By the way, all the program, if you want to run, you have to have a main function. Main function is telling the operating system that this is a starting point for the execution of the program. So inside this main function, I just show you a very simple example. It basically called box, first box. It basically say, hey, I want the first box as a variable, as an object, following the definition of class box. So that's why I say box, first box. And then you're doing something else like a bracket initialization. And because you use that definition of box, you can see that the first line of main.cpp, you also include box.h. So essentially, both box.cpp and main.cpp, they both have this line of include box.h. They both include the definition of class box, but the purpose is different. The purpose of box.cpp, this is very important, is for the implementation detail about the box.h, while the main.cpp is just the user scenario is I want to use the definition of box to do something. Okay, this separation is important because later you will see that how we leverage this to implement the idea of encapsulation. Okay, let me show you further example. So I'm actually going to compile both box.cpp and main.cpp. You can see that I now put in two lines. One is G++ minus std is equal to C++ 17 minus C box.cpp. And the other one is G++ minus std equal to C++ 17 minus C main.cpp. Okay, I do want to mention something. That the reason you saw my previous example was always about C++ 2a. And I realized some of the platform, they haven't up to date to C++ 2a, such as the WSL, Windows subsystem for Linux. The last time I tried, they actually only support C++ 17. And C++ 17 is actually very up to date. And then most of the example should be supported by C++ 17. So I think it will be safe for us to assume that you all have access to C++ 17. Okay, so this is the compiler. So we compile this two program, box.cpp and main.cpp separately. And in each of the compilation, the compiler is going to read the box.h because it has been included in this compilation. And from there, they're going to generate the .o file. So for the first line, the top line is going to generate box.o. And for the bottom line in the main, that this is going to be generate main.o. Okay, so you have a separate compilation into an object file. And then I'm going to show you the next slide. You see that there is something called linker. And the linker program is going to link these two together, link the main.o and box.o together. Then you have an executable program. Okay, this is because main.o provide the entrance of the executable, which is the main function, main, while the box.o provide the implementation of the box. So if you put this two pieces together, you have a complete executable program. So that gives you some idea about how we can start working on something from a complex system as a requirement for us to solve to the object-oriented modeling, to the programming, to the compiler, and to the linker. Now you have an executable. And now what you can do is that if we have done a good job in modeling all the major objects in the original complex system, and now we're executing this program, we're basically provide a really strong digital twin situation for what we like to solve. Okay, so this hopefully gives you an overall picture about what we have been doing so far. Why do we need object-oriented modeling? Why do I need object-oriented programming language? Why do I need separate compilation? And why do I need linker to put this whole thing together? And to show you in this slide, it actually shows you the whole thing step by step. But there is one thing I would like to emphasize is the principle of encapsulation. So I mentioned last time, for example, box.h and box.cpp was developed by a commercial company, and the detail about how they implement box.cpp is their proprietary knowledge. So when they release the software for people want to use the concept box to mimic the complex system, should not be released to the people who just want to use the box. So in other words, typically what happens is that when you generate this object file called box.o, that file along with a bunch of other .o file related to a variety of objects being put together into some kind of library. For example, it could be libobject.a. And in this case, that you don't see the source code about the original .cpp file, but it's okay for you to compile with your main.c because you just need to get main.o and link to that library file, libobject.a, and then you will be able to get the executable. So this is a very good situation because now I can, through the box.h, by the way, the company will not give you box.cpp source code. They will give you both the libobject.a, which is the compile object code for all the library function, and also they give you code like a box.h because box.h is necessary for you to compile the main.cpp. And therefore, by the concept of encapsulation, you kind of know the interface. The interface is provided by box.h, and the detail is being compiled, and you can do your work, and then the company's secret, their proprietary information will be protected this way. Okay, so this hopefully gives you an idea about everything we talk about, including the principle of encapsulation. Okay, so before I jump to the topic, the operator overloading, I want to talk a little bit about software development environment because this has been a lot of questions come up from the last week that people either ask in the session or office hour or offline. They ask me a lot about development environment. So I know a lot of you are using CSIF. So you're using CSIF terminal mode, and you just using a command like a SSH with your user ID, and then log into one of the machine they have, which is maybe PC 15, and then .csiucdavis.edu, and then you basically work on your homework. So you basically develop all your homework under CSIF machine and use your account, and then you submit, you hand in your homework there. I highly recommend you to consider doing another thing, which I call local development. So what do I mean by local development? It means that when you develop your program, you don't need to use CSIF. You use your machine. You use your laptop, desktop, or if you have Android, actually, you can do that as well. So local environment, it will also give you a terminal. So this terminal, this terminal maybe is a Mac OS terminal, or maybe is a Windows 10, and maybe this is Ubuntu, Linux, Windows, or Apple. You can choose. You can actually develop the terminal. But the difference between using local development and CSIF, because currently CSIF does not support, the best of my knowledge, support for a industrial IDE such as Visual Studio Code, which is the most popular platform according to the commercial survey. So if you use the local development, that you can actually start using Visual Studio Code and integrate it. Of course, if you're using Mac OS and Ubuntu, you shouldn't have any problem. But if you're using Windows 10, I wrote a report. The link here, I posted on Facebook. I also sent you via Canvas that this is a report about why you should use Windows and upgrade to Windows 10 and install something called WSL. It stands for Windows Subsystem for Linux. And then based on Windows 10s and WSL, you can actually easily integrate it with VSC, Visual Studio Code. And the diagram, it looks like this. So it's really interesting that I realized it's not just using WSL and Windows and VSC together, but the architecture is doing what we call remote development. You can see that this slide on the left is running on your environment. It basically gives you a nice GUI and editing environment that you can develop your code. But when you execute the code, it will be moved to the other side, which is the WSL side, which is the server side. By the way, this server right now, based on the tutorial I provide, is going to also running on the same system. But this part, WSL on the right side, it can be put in a different machine. It could be put in a cloud, put it in a much bigger machine that has a lot of GPU unit for very advanced application that require a lot of resources. And in general, this is a really nice for you to work on. And also by doing this kind of local development and connected to such a remote server like a WSL, it has a lot of advantage. I mean, for example, if you are traveling or your internet is not stable, and then you can actually continue to do your local development without being interrupted by a power outage, internet outage, and you can still doing work. And then when the network reconnect, then you can actually easily synchronize with your server side. So this is going to be a really useful experience. And also, I want to suggest to all the students is that through this process for you to install the software and then try to run it, you actually learn more than programming. You learn the system architecture. You learn how to follow a new style of development environment, how to install. For example, if you want to install Windows 10, you need to use something called PowerShell, which if you don't need to do WSL, you probably never need to use PowerShell. And you need to know how to do PowerShell as an administrator, which is really the way you click the mouse. And then when you invoke PowerShell. It's not difficult, but it's just, if you know how to do it. And we're here to help. I'm here, the TA are here. We can help you go through the process. Once you go through the process, you actually know how to get access to a much, much larger set of resources that industry companies such as Microsoft, Google, and Amazon, they develop, and for you to make your programming experience a lot more effective and broader. Okay, so this is something I really want you to focus. And also, I will start to talk about homework assignment number 2. So this is a very high level, 10,000 feet level to look at what homework 2 is doing. So homework 2 is doing the following. It's essentially you're going to write a program, and the program is going to, just like homework assignment number 1, but you're going to send not just the student ID, but you also send a virtual name, a name you pick. For example, you can say, my name is Pikachu, or my name is Captain America. You pick whatever name you want, but then you submit your real ID. Okay, and of course, this too need to be submitted as a JSON format. And then the server is going to get back to you with 2 things. One is called a virtual ID. So virtual ID is a string of number. It's like your student ID, but it's not your student ID. The virtual ID is going to sum of the random number we generate, and you're going to use that number subsequently for every single class activity that within ECF 36B this quarter. Okay, so remember that. If you forget about that, you have to contact me. I will pull it out for you. Okay, and then we will confirm with that virtual name for you. Basically what you have submitted. Okay, so that's essentially what homework number 2. I will release the full detail maybe next 2 days. Okay, so this is homework number 2. But more thing I want to tell you is that I realize that I really want to encourage you to do more programming, to get online, to actually spend more time with the class. And I know this is important because for you to learn, for example, my lecture, last lecture or this lecture, you have to try the program yourself from Horton's book, which is very important. And I decide to shift the grade a little bit to have 20% of your grade. That's actually depending on what I'm going to tell you right now. Okay, so what I'm going to tell you right now is following the same principle. I want you to run the program example in the textbook, and also sometime I will give you some extra program for you to actually run or make some slight modification. And how will that work? How will you get to that 20%? We're going to use exactly the same style of interaction like your homework assignment number 2. So basically, you're going to use a client program. And by the way, this client program we're going to develop. You don't need to worry about writing the client program, but you can imagine this student client program is very similar to your homework assignment number 1 and homework assignment number 2. They're almost the same, but we will give you after you submit your homework assignment number 2. Okay? So this program, you're going to submit 2 things to the server. So we're going to have a server, a special server called ECF36B server. And we'll tell you the IP address and how to contact that server, just like homework assignment number 1. But you're going to send a JSON with this 2 pieces of information. The first piece of information is a virtual ID that you obtain from homework assignment number 2. Okay, don't use your student ID. We don't want to hear that. If I see you use your student ID, you're in trouble. Okay, so use your virtual ID, and then just put a string saying that, hey, I want to program. When you say that, the ECF36B server is going to reply you with 3 information. So the first information is a virtual ID. They want to just tell you, hey, I got your ID correctly. And the second thing is that, well, we totally have 20% about the program that you feel you need to run, I want to tell you how many of those you are already finished running and submit the right result. You will see how you get build up that 20%. And then the third one is that I'm going to tell you that now you need to run this program. For example, right now we're in chapter 12. I will tell you the next program you should run is the EX12_05. And that is a program under Horton's book. I will give you a pointer so you will know that which program that you're supposed to run or supposed to modify and get it run. So all this 20% of the program is either you don't need to make any modification, means that you just compile, run it, and get a result, or you make a very simple modification. So this is not for you to, like your regular programming assignment, you need to build a large chunk of code yourself. And this is just a simple thing, but make sure that you're on track with what we're doing in lecture and on track with the example. Okay? And after you receive this next program to run, what you do? Now you use your whatever environment, crafting the homework. Okay, you do your homework and then build that homework and get the result. Okay, and that's what you need to do next. And then after you obtain the result, this is the using the same program, student client and the ECF36B, you will submit the virtual ID and also the program ID, and also the output from the program. You cut and paste the output from the program, and then put it into the JSON, and then the whole program will be the whole thing, the three things: virtual ID, which is your ID; program ID, which program you're working on; and then the output. And then the server will immediately get back to you to say not just the virtual ID, program ID, but it will tell you whether that output is successfully submitted or actually the output is actually not correct. So if it's not correct, of course, you need to try it again until you get it right. Of course, at this time you can ask TA, ask the professor to help. Okay? And then we will also tell you if it's successful, you will see that your progress about that 20% improve. So you actually, through this program, for you, you know that how many of that 20 points you already get, where you are in that process. This is also good for me as an instructor. I will know which of my students, they actually complete all the homework according to the lecture, or the example, and which of my students are kind of a little bit behind. For example, we're already in the middle of the quarter, you haven't even done the first example. Then I, as an instructor, I will concern, and then I will probably contact you very gently to ask you whether you need some help. Okay, so this is really a mechanism to kind of have fun about this interaction, but important thing is make sure that you're on track, and then make sure we know that you're on track as well. Okay, so hopefully you will be receiving this instruction very soon regarding this 20%. Okay, so I'm going to start to talk about now. I finally start talk about the operator overloading, and just repeat this again. This is now we're in chapter 12 of Horton's book, and you can download that particular chapter from the local server, or you can go to the UC Davis library online to actually download the whole thing. So we're going to talk about operator overloading. So I'm going to talk about two things very quickly. The first thing is, what is operator overloading? And the second thing is, why do we need to have such a mechanism for us to overload the operator? Okay, so first let's look at what is overloading. So what is an operator? Operator, there are so many operators. There are greater than, there are Boolean operator, there's assignment operator, there's all kind of operators, such as function is an operator, bracket is an operator. There are so many operators. And those operators, based on the programming language, usually only operate on some basic data type. For example, plus and minus or division, they work on numbers. And or some of the operator maybe work on string or work on character. So they are actually, the operator are being used to let us operate on the basic data type that we have. However, when we get into the object-oriented world, we're dealing with objects. And therefore, we like to extend the semantics of those operators to include the operator to capture operand as objects. For example, we know 1 plus 1 is equal to 2 arithmetically. But what do we mean by a box plus another box? Or a person add another box? Or a person add to another person? And that you can see that I'm actually trying to redefine the semantics about operator in the context of operand, not as a basic data type, but as a abstract object. Okay, so this is the reason or what is operator overloading. That's the concept. So now I'm going to tell you why do we need the overload, the operator. So last time, this is in fact EX11 underscore 02, that we define a class called cube, the class cube. And under class cube, there is a public function. I already put it in the slide. There's a one member function, public member function called compare volume. Okay, so compare volume basically say you take another cube object as operand or as argument into this object, and I try to compare their volume. Okay, so that's essentially what the compare volume is doing. So if you look at the code, that this code I put it here, that this is the piece of code from ex11 underscore 02.cpp, which great for you to now to take a look at the code and see in what context we have. But here's a few lines that are related to how that public function was called. So it says here, if parenthesis box 1, which is the object, dot compare volume, which is the public function to that box 1, and I put box 2 into as the argument, and then if this is true, then basically I print out box 1 is larger than box 2. Okay, so in this example, compare volume, that is very clear. I'm actually comparing their volume of these two different cubes. Okay. However, if you look at this statement below here, the if then else statement is kind of not so easy to read compared to this statement we see the next slide. So now I'm actually going to show you the version of the original statement, which is on the top, using box 1 that compare volume, and the statement below is the same code but using the operator overloading concept. So in this statement, you can see that it basically the statement is just if box 1 is greater than box 2. Okay, that's very clear, right? It looks really nice because not only it's I don't have to try to understand what do you mean by compare volume, but I already know what's box 1 greater than box 2. And also remember, box 1 is not an integer, is not a floating point. It is an object. So now I'm actually be able to, have an if then else statement to compare two boxes together. Okay, so that's called operator overloading. It makes the code looks nicer. In fact, I want to just emphasize the important thing about operator overloading is that it really supposed to give you a much better code readability. I mean, this is very subjective. Some people actually like the original version, But this is when we design operator overloading. This is really what we want to do, is that we want to be able to use the operator overload with a new semantic for abstract object, and then we will be able to read them more naturally. Okay, this is actually a tricky point for you to consider. I will argue that operator overloading is really for better code readability, not for convenience, not for showing off. Okay, by the way. In other words, I want to give you a warning early on here, is that if you use operator overloading and you sacrifice something such as readability, your readability is poor or worse, then you should consider whether you should use a concept operator overloading. Okay? Okay, having said that, so now let's look at how you can actually really implement the, so I just define, how do you actually really define something called operator overloading in this example. So in this slide, you can see the button is exactly the one I showed you earlier. This if box 1 is greater than box 2, right? That's a code. But how do I do that? In order for me to do that, I have to have the definition on the top. That, by the way, this is from EX12_01. Is that you see I have a class box. That's my class definition. And what you will see is that inside this function, I have a function defined called operator greater than. So I use the keyword operator greater than. When I do use the keyword operator and greater than, then this function is a overloading operator. It's overloaded operator. So it returns a Boolean variable, and it takes a parameter called another box. It's a reference to another box. And also what it returns is just return my own volume if it's my own volume is greater than that box volume. Okay, so you can see that this is the implementation is very similar to what we done before, the traditional way, which is compare volume. But now in the driver program, it looks nicer because you can say box 1 greater than box 2 because that greater sign has been overloaded by box 1. Okay, and by the way, there is something which I want to point out. There is something now you see is called constant, const at the end of definition. I just want to tell you that that constant means that every single object that go into this particular operator overloading is not going to be modified. Because it makes sense, right? I'm just doing a Boolean comparison. I'm not supposed to change the value. It's just suppose I give you two values, tell me true or false. And through this process, this function is not allowed to change anything about neither of the object themselves. Okay, so that's the first example I want to show you about operator overloading on the greater sign. Okay, normally at this moment, I will ask students for a question, but now in front of me is just the camera. I won't ask you that question, but on Tuesday, you can ask me a question, okay? All right, so take a look at the code for 5 more seconds. Now I'm going to tell you about what kind of operator you can overloading. Okay, so typically all the operators that you can overloading. I mean, you can do greater than, equal, not equal, and or all the arithmetic operator, plus, minus, star, and also assignment. And also, in fact, the output, the cout, you see that 2 greater than sign, you can overload that as well. You can do plus, equal, and you can do bracket, and you can do parentheses, which means that the function itself can be overloaded as well, which we will see that. But there are 5 operators you cannot overload, which I put here, 2 colon, that's a scope operator. Okay, you will see some of the example I present to you. What do I mean by scope operator? And there's a bunch of things like dot, you cannot overloading that. Dot star, you cannot overloading that. Size of, those things you cannot overload. But except those 5 operator that you can overload anything. Okay, we'll see some example. Not this lecture, but next lecture. But now I'm actually going to give you some warning about operator overloading. Important thing is that why do you need to learn operator overloading? So in programming language, there's something which is your right to learn. Is that, okay, I teach you a new programming language construct. It's just a language. Why do you need to learn this? Okay, so I want to tell you that this is important. The reason you want to learn this is that you want to be able to understand somebody else's code. For example, you took over a project, your predecessor used a lot of operator overloading. And you need to know that. You need to know what is operator overloading such that you won't misunderstood, because this greater than sign is not as greater than sign without operator overloading, right? I mean, for example, I do want to tell you that in C, if you do box 1 greater than box 2, if you're not doing overloading, so now this is for people who understand C, what you're doing is compare their address. Because box 1 is the address of the object. You're comparing 2 address as an integer. Which one is bigger than that? But if you're doing operator overloading, then you know it's comparing volume. So to understand the operator overloading, it's very important for you to understand somebody else's code. Okay. So I also mentioned that operator overloading is really for better code readability. So for yourself, you see that I kind of changed my style here a little bit. I said you need to make, as a programmer, you need to make a sensible decision whether you should do overloading or not. Because sometimes overloading is really good. So pretty much we decide that if the situation is really appropriate, yes, doing overloading is a great thing. But if you just want to do overloading for all the object, I think you will create a lot of disaster situation. Let me show you some example. Okay, so let's take a look at this slide. This is the example I already showed you, which is box 1 greater than box 2. So in this example, that we know the meaning of greater than. We know the meaning is the greater than is really compare the volume for a class box, and also partially because there's really only one public function, so you can check your box.h. You say, okay, there is only one volume, and therefore it should be the only one that's comparable. Okay, so this box is simple enough, so you have a greater than. Great, you can get it done. Okay, however, let's change to a different class. In a real complex scenario, we always like to compare person. So if I give you this piece of code, say if person 1 is greater than person 2, and if this is true, you print person 1 is better than person 2. If I give you this piece of code, is that very readable? Not necessarily, especially if this piece of code is developed by a software company and they don't give you the source code. They just give you the object code and give you the .h file. How would I know what this means? I mean, this could mean you're comparing 2 person, their volume or their height, their age, their blood pressure, or how many hairs they have, or IQ or EQ. There's so many things you can compare with person 1 and person 2. And I'm confusing because at this moment, I don't know what perspective of that person has been overloaded through this greater sign. if you do that. I'm kind of give you an extreme example, but you can see that sometimes when you compare the operator overloading with two objects, when the objects are fairly complicated, there are so many things could possibly be interpreted. Okay, so therefore, it's important for us to find out, for me to use this code correctly, I have to know the precise semantic meaning about this overloading operator. Okay, so if I show you earlier, the slides I show you here, so if you look at the class box operator, in this slide, you can see that the code, the implementation is already included in the class box, which is not supposed because we want to support encapsulation. In a real situation, it will look like this. Just show you. It will look like this, as I show you here, that you have a class person, and it has a Boolean operator greater than, and has a argument, which is a reference to an object, and say const, semicolon. So it means that I only give you the interface. I didn't tell you the details. So you wouldn't know unless you look at the person.cpp, which now I show you the person.cpp. It says Boolean person colon colon. Remember, now we see colon colon. That's called scope operator. That means that this operator is under the class person, and that colon colon is one of the 5 operator you cannot overload. Okay, that's another point. But now you can see, unless you look at the person.cpp, now you know they really compare the blood pressure. They compare the blood pressure of person 1, whether that's greater than the another person's blood pressure. Okay, so essentially, this kind of knowledge is hard to get unless you already work on the same software development team with people who wrote this piece of code, or you have to read the original source code, person.cpp. Okay, but what does that mean? That means now I go back to the first part of my lecture. I send you this picture. Why am I compiling this box.h and box.cpp separately? I want to implement encapsulation. I don't want people to know box.cpp. But see what we're doing here? Now we have a person.h and person.cpp. In order for you to use person.h appropriately, because they're using operator overloading, I have to give away person.cpp. So in some sense, I'm sorry. Because of this, we broke the principle of encapsulation. We violate the principle of encapsulation in order to support the operator overloading. So this is an example. I want to tell you that operator, 2 lessons. Number 1, operator overloading is a good tool for you to enhance readability in some cases. But on the other hand, at the end of this lecture, I just want to tell you that in general, when you apply different principles, encapsulation, inheritance, data abstraction, and polymorphism, you start to realize there is some conflict among this principle depending on how you do it. Today, I show you the example. You try to do overloading. I'm sorry, you broke encapsulation. And multiple inheritance is another one. I'm going to tell you it will break a lot of things in object-oriented principle. Okay, good luck. I will see you in class. No, see you in class means Zoom in class on Tuesday. Okay, bye.